Hello YouTube, this is Jay Kilroy coming to you here from the shop. We're going to do a little CAD work today. If you remember at the end of the last video, I showed you two rough castings of some faceplates for that I had cast years ago. I would say they're appropriately stress relieved, i.e. rusted. And I want to machine those to utilize the D1-3 mounting on my Revette 1020F. So what we're going to do today is do a little CAD work on drawing a D1-3 connection. And I have a bunch of paper drawings, all sorts of reference drawings. There's all sorts of stuff available on the net. So why are we going through this process? Because I like to, because I do believe, like I've said before, that better drawings make better parts. And it is very helpful for me to go through this process before attempting to machine the part. There are some call-outs in the D1-3 spec, plus 0, minus 5/10. So there's some sure enough numbers you have to hit here, or you scrap the parts. So the first thing you might notice here is that I have changed my CAD package. I've done a couple of other little drawing videos on Creo Pro, which is a freely available CAD package that I've used for quite some time, and I really do. I can't complain about it. It's been very good. But I have changed to Solidworks, and and I've been real pleased. I've only been using it for a few days. I am not a CAD professional. This is not what I do for a living. So this is not so much a CAD demo as it is a discussion about the particular features of a D1 style chuck or faceplate mounting. But anyway, I did make an investment into SolidWorks, and I have to say that I'm pretty pleased with it. I've got my resolution. I don't normally use this resolution on my computer, but I've got it compressed here so that it's easier for the viewers to see. So let's get started with a new drawing here. New part. Whammo, here we go. And like I said, I am not a CAD professional, but I gotta say this is it's pretty easy for me to use, right? So the call out on the boss, the OD of the boss as it attaches to the spindle nose, is 3 5/8 with a 16th chamfer. I don't know why the OD is all that important, but they call it out to -0 plus 2 thou. So anyway, this is the OD. So there we go. That is set up. The ID is the tricky part. There's an angled hole that rests on the angled boss of the spindle nose. That angle is 3 inches per foot included angle, both sides, right? So that works out to about 7 1/8 degrees. I'm not going to go over the math, but there's plenty of ways you can figure out on Google how to solve a right triangle formula to figure out that included angle. So 7 1/8 degrees is the angle we're going to use. The diameter, and this is probably the trickiest feature in the whole part, the hole is called out at 2.1250 plus 0 minus 5/10. That's pretty serious there. So we are going to actually, you know what? We're going to get rid of that first. First thing we're going to do is we're going to extrude this thing to give us a solid to work with here. There we go. That's better. So there's our 3 5/8 OD. Now we're going to sketch on the face here our 2 point 2.1250 ID here. And let me change that. Now this is a extruded cut that we're going to take out here, and it is a taper, and our taper is 7.125 degrees. So let's do that. Whamola, there she goes. So starting to look like a part. So let's get a view here. So there's our tapered hole through the middle at our the proper angle. So let's see, calls out on both of these for a chamfer on the outside of a 1/16 of an inch, and on the inside of a 32nd of an inch. So there we got our two chamfers are ready to go here. So now we're going to lay out the holes for the mounting pins, the cam lock pins, and the locking screws. And this is probably these are probably some of the features that you don't see a lot of videos on YouTube, people making D1-3 mounts. You see a lot of people making threaded mounts, but not a lot of people making D1-3 mounts. And as some of these fits, like this tapered hole and these pins and lock screws, that might be the reason for that. So hopefully we can make this work and we can take some of the mystery out of it. First thing we got to know is what diameter do the cam lock pins lay out on. And well, I don't have a diameter in all my drawings, but I do have a radius of 1.391. So what we're going to do is we're going to come back here and we're going to draw a construction line for that. Let's go back to our top view. That is 1.391. That's our radius, our diameter of 2.782 is the diameter for the mount pins. This is for the cam lock pins, right? So here we are. Now the cam lock pins are hold on, I need a center line. That'll work. The cam lock pins are, for this size chuck, for the D1-3 chuck, are 7/16 fine thread. They're basically set up like a counterboard socketed cap screw is kind of how you prep for that. So in Solidworks, like I said, I've just started using this stuff. So we're going to choose socketed cap screw, ANSI inch, 7/16, and then it pulls up all of these sizes. This is just out of a library, and we are going to change a few of these because the pins aren't exactly what you would call standard. And these dimensions are all given to me in 32nds and 64ths. So you know how old the drawings are that I'm looking for. And it's a blind toll. 1 1/8 inches deep. That looks good. So once you've done that, you go to position, you choose your face, you pick a spot. Where are you? Having trouble choosing my spot. Booyah. So there we are. We got one hole defined for a lock pin. Now the kind of tricky part, for the mount pin, the kind of tricky part is for the lock pin, how do you lay that out? They don't give you a diameter on that. What they do is they give you an angle and an offset relative to the center line of this hole. So the angle's 18 to 18.6 degrees. There's the range you have to work with. So let's come in here. Let's draw a line. Oop. And let's set that angle to 18.3. How about we'll just split the difference? And there you go. 18. Then there's another line. You have to draw a line perpendicular. And that line is not, the length of that line is not important. So, then we have to draw another line parallel to our original line, and then they specify an offset, and that's how you figure out where your pin goes. And this dimension, this offset, is set at 0.437, and it doesn't give me any tolerances on there. It says, it gives me a note here: holes located as shown within 4 thousandths radius of true position. So there we go. So this is where the locking pin goes. With the pin location for the locking pin, locking screw, I guess you could say, established right here. Let's discuss the locking screw. Locking screw on a D1-3 is a 1/4 by 20 socketed cap screw with a slightly smaller head diameter and counterbore depth, but other than that, it's a 1/4 by 20 socketed cap screw. So let's exit sketch here. Let's go back to our hole wizard. Leave it there. Change this to a 1/4 inch. And let's check all of our dimensions here. This is a little smaller. And I think it's a little deeper actually. So and the depth for the hole is specified as 13/16. So let's place that baby in here. And there you go. So we've got our one mount pin and one locking screw set in position on our kind of virtual D1-3 connection, as it were. So the next thing we need to do is, well, we don't need one of these, we need 3 of these. So how are we going to do that? Well, there's hard ways and easy ways. Obviously, the I guess more difficult way would be to put layout lines in here and then copy these features around. Or you can let the software do the work for you, and that's what we're going to do. So we're going to come in here and choose these 2 features. We're going to do a circular pattern around this circle. We want 3 of these, and we want to space them at 120 degrees. There you go. Boom. And there you have it. We've got 3 sets of cam lock pins and locking screws set in place for our virtual D1-3 backplate here. Next thing we need to do is create a drawing to lay out. Let's say we make an assumption that we're going to do this part on the mill, this piece of the work here. We're going to lay the faceplate up on the mill. We're going to pick a 0 up here with our DRO, a 0, 0 in the center of this part by just centering on the OD of the boss. And then what I need is relative X and Y moves to lay these out. It is entirely possible that, and on my DRO I know I could do it, you could use the DRO circular hole function to lay these pins out, and that works, but that's kind of specific to what kind of DR you have. So what I'm trying to produce here is a set of X and Y dimensions from a center to help you lay out this whole pattern, no matter what kind of DRO you have. So let's create a drawing. So let's new drawing from part. Top view, drag it over. Let's change our scale here. So this is life size, I guess you'd say. And what we want to do is we want to come up with a set of dimensions to allow us to start from a 0, 0 point here and to do each of these 6 features. We got 6 locations to work with basically. So really this is pretty straightforward. Let's start with vertical dimensions. Reference this datum here, and there we go. So that's obviously the easiest one because it's just straight up. And we'll do some more verticals here. So that's obviously for both of these circles here on that center line. Then that one there. That one there. So there's all of our verticals. And then let's do some horizontal dimensions. Reference that line to there. So there we go. And these should be equidistant. They are. And here. These will not be equidistant. So that's pretty much all of our dimensions there. Everything we need to go from a 0, 0 position to all 6 of these features. Let's get some more decimal places in here. And yes, I could use the hole pattern functions on my DRO to lay these out. But this is pretty simple here if you can create these dimensions here. So we're going to go ahead and create a couple of dimensions for the this dimension here is the radius of the mounting, the cam-lock mounting pin radius, and then this dimension here is the actual radius of the locking pin, locking screw radius. So if we want to use our DRO function for the locking pins, we could start at 18.3 degrees, the way we have it drawn, and then we could do 3 equally spaced all the way around. And we could use this as the radius. So, you know, it's worthwhile. I guess having more data is better than less, right? So I throw a few more. We'll pick our center line, our internal hole here. That let's see. We'll try it right here. That's that 21250. Picked up the wrong one. I got the chamfer. Anyway, so this is a drawing that has all of the dimensions needed to lay out your D1-3 backplate. Okay guys, I went ahead and printed out the drawing and cut out a copy of it. One of these castings already had the Boss OD machined to a rough size 3.63, so just about 5 thou oversize. And I just wanted to kind of sanity check myself and look at that and lay this up here, lay this over the back of a chuck and check my hole locations and everything. I'm going to go ahead and post this drawing in my Dropbox. There will be a link down below, but realize at this point it is yet to be tested. You might not want to use it until I successfully chuck this thing up in the machine. But I'm going to go ahead and put that out there for you. I'll put links to the actual Solidworks files if there's any Solidworks users out there that want a copy of that. And got to figure out how to chuck this thing up and use some of the information recently gleaned from Ox Tools channel on setting angles and turning precise angles, because I need to turn this this ID here to a 7 1/8 degree angle to a very precise fit. So I don't know that I've ever turned anything to a +0 -5/10 number before, so this ought to be interesting. And if I bore it oversized, then I guess I'll turn this thing into a stool. So we'll see how it goes. So anyway, I hope the video wasn't watching paint dry. I hope you got some good information off of it, and we'll be back with you soon.